Hello everyone. I'd just like to give a presentation now on the process that we will be using to develop models for looking at cumulative impacts of deep sea mining and potentially from other sources of pressure as well. This process that we'll be working through will develop some very general models that describe the ecosystems and describe the pressures that are acting on those ecosystems, how they interact with each other, and give us an idea of the sorts of outcomes we can expect from those sorts of pressures on those ecosystems. They're a model that relies on the expert knowledge that all of you bring to this workshop, and we'll be using that expert knowledge over the next few days to develop these models. It comes down to the models that we develop really come down to your understanding of how the ecosystem works and the way that all the different pressures can act on those ecosystems. We'll be looking at these developing these models for three different systems: for the seamount ecosystems, for pelagic ecosystems, and potentially for manganese nodule ecosystems. We're working off a process that is the basis for adaptive management. This process starts out with a clear understanding of the objectives and the desired outcomes that we are trying to achieve for the ecosystem and for the ways that we are using it. It relies on a process to develop an assessment that includes all the potential positive and negative effects of any sort of development and resource use. And finally, a monitoring program that can test the types of assessments that we're doing and ensure that the outcomes that we've identified are actually being achieved. We base this work off a much larger piece of work that really steps through each of those three steps: identification and of the outcomes, assessment and evaluation, and monitoring, which is a much bigger and potentially more complicated process. But the process that we're concentrating on in this workshop is really the assessment process. It's understanding the potential risks and impacts that are going to come from any sort of development and where they are acting. In particular for this work, what we're concentrating on is cumulative impacts and understanding how the different sorts of uses and pressures that are acting on ecosystems can cumulatively act to change the ecosystem and to alter the state, and potentially mean that we won't achieve the outcomes that we're actually desiring to achieve. We're building this work out of a series of work that CSIRO has been doing for a long time, and has worked on really developing 5 key steps to support an assessment process like this. The first thing we do is identify the pressures and the values that are acting on the system. So the values here are the ecosystem components, the parts of the ecosystems that are important to us and also provide important services for us, and then the pressures that are acting on those ecosystems. And they can be both pressures that are coming from anthropogenic activities, but also pressures coming from natural processes that are occurring that might change the ecosystem, such as things like natural variability in climate and other sorts of climate signals, potentially climate change. We're combining that information in causal models that describe the relationship between the ecosystem components and the things that we care about, that we value, and the pressures that are acting on them. And what the causal models do is they describe the pathways that the pressures can act through the system and the potential outcomes of what those pressures are, both singularly and also in combination. At later points, we can start to look at the zones of influence, which is really starting to see how far and how complicated the intersection between pressures and values are, and overlaying that to give a more regional point of view. And eventually, once we combine things with a proper monitoring program and quantitative data, we can start to understand the quantitative risks and uncertainty associated with any sort of development and the way that developments are progressing. The key thing, though, that we're going to do over the next few days, though, is develop the causal models so that we understand potentially how the values and pressures are actually interacting with each other. What we're doing here is it's an expert elicitation process. So we're working with you to get your understanding of the way the ecosystem works and the way that the different pressures are acting on those particular ecosystems. So conceptual models. These are really a tool for low data risk assessments. It's a working hypothesis for how an ecosystem works. So what we're doing here is we're coming up with a hypothesis for the system. We're not measuring the system in any particular way, but we're describing how our internal models of how we think the system works and the way it operates. As part of that, what we do is we identify all the important components of the system and processes in the system. We document how these components and processes are related to each other. We identify all the links between the ecosystem components and anthropogenic pressures. And finally, and equally importantly, we're able to identify where the knowledge gaps are. So because we work through quite a rigorous process of describing the ecosystem and the way that pressures act on it, it becomes very clear where we have information that is unclear, uncertain, and where we have other sorts of key uncertainties. So we'll be concentrating over the next few days on constructing those conceptual models for the different ecosystems that we're considering here. The process that we will work through to develop these ecosystem models is done in 4 key steps. The first is to identify the bounds of the system that we're interested in. So how big an ecosystem are we considering, and how many different ecosystem components might there be part of it? We usually talk about just limiting ourselves to specific ecosystems and not being too broad, because that makes the models both tractable and also understandable. We're then going to identify the ecosystem components and subsystems in those ecosystems. We're going to describe each of the components in the ecosystem and potentially some of the subsystems in those ecosystems. That will include things that we think are particularly important, particularly valuable in some cases, and we can identify those. We'll then work through a process of identifying the natural pressures and also the anthropogenic pressures. So where are we expecting to see change in the system as a result of the naturally occurring processes and pressures that are changing the system, and where are we expecting to see change as a result of anthropogenic pressures coming in addition. Then what we'll do is develop models of ecosystem structure by describing the relationships between all of the ecosystem components, and then so that we actually have an understanding of how the ecosystem operates. Then we'll start to consider adding in changes that might occur as a result of potentially natural pressures and also anthropogenic pressures. And so we'll work through those lists of the anthropogenic pressures that we've developed and identify where in the system each of those anthropogenic pressures is actually going to touch the ecosystem. What we have done before, to give you an example of the process and the outcomes that we're expecting, is develop exactly these sorts of models for the polymetallic sulfide exploration activities in the northern mid-Atlantic ridge. What we did there was we really identified the values, the pressures, and the zones of influence, the spatial context, so that we could understand and develop those causal models. So the first thing that we did was really map out what all of the different ecosystem components were. And you can see here in this screen, this is the rough process that we used to describe the ecosystem components for the vents ecosystems in the North Atlantic. And each of those circles there is a ecosystem component, and then the arrows and the lines ended in the solid line indicate either positive or negative interactions between those different components. So in some cases, a ecosystem component has a positive effect on other ecosystem components, and other cases, ecosystem component where, for example, when something is feeding on something else, has a negative effect on that ecosystem component. We then formalize that in a much more formal source way, and you can see in this picture, and add in the information on the different sorts of pressures that might actually be coming in on the system. So we start to get an understanding then of how the system operates, both in terms of its internal dynamics, but also in terms of how different sorts of pressures will actually come in and change that system, and which particular ecosystem components those pressures actually act on. We then develop a table, and we'll have a number of these that will be distributed, has been distributed before the workshop, that talks about the ecosystem components, identifies where we're expecting some sort of change, where we're expecting the change to come from, a description of what that change actually will look like, and some scientific references to actually back up that extra information. So what we end up at the end of the process is a qualitative model, such as the one you see on the right there, and a table document that describes each of the links between each of those components, where the link is coming from, and the scientific support for that particular information. What we then do is document all of the different sorts of pressures and perturbation scenarios. So how do we think the different pressures are going to act in singly and also in combination with other pressures? So we get to see some sorts of pressures, for example, habitat removal, what the pressure actually is, and what the direct effect of that pressure is actually acting on, the description of what that pressure is, and the reference to describe that particular one. What we can then do is start to explore different scenarios for combinations of pressures. So we'll identify a particular scenario where we think a number of different pressures will act at the same time on the ecosystem, which represents either a active exploration or mining operation, or interaction between two different sorts of sectors that may actually occur in particular locations. The outcome of this process is we use a process of mathematical modeling to understand the expected change in the system as a result of the different pressures that are occurring. So you can see here on the left, these are the different pressure scenarios the pressures that we identified for acting on the active vent systems. And then on the right, what you can see is the result of the qualitative mathematical model that describes the likely outcomes of those different pressures on the individual ecosystem components. So the red there represents for particular scenarios, for particular pressures where we're expecting to see a decrease in that particular ecosystem component. The yellow means we're not really sure whether it will increase or decrease. The orange represents where we think it will decrease, but we're not as certain that it will decrease. The blue indicates where we're certain that it will increase as a result of particular pressures. And it's important to note that because of the structure of ecosystems, sometimes when we change an ecosystem, some things will increase as well as decreasing. So we don't necessarily always see a complete reduction in an ecosystem. And we can also look for the likely positive changes where we think there will be a change, but it's not a really strong change. And also where we're seeing no change at all. So there are large parts of the ecosystem potentially that are not impacted by particular pressures or combinations of pressures. And that's because those particular parts of the ecosystem are not linked in any way to anything that those particular pressures can change. So that's the key output that we will be aiming for as part of this workshop, and potentially some of the work afterwards, is to develop a table that looks exactly like that for each of the ecosystems that we are considering, and all of the different combinations of pressures and the scenarios that we want to explore. That's the output that will come out of the workshop. The steps that follow after that are where we actually start to use these sort of information. These are not going to be considered as part of this workshop, But they are the key next steps that we'll have to actually start to think about. So what is that? When we start to think about things, we need to start to think about the monitoring questions. What will be impacted by what pressures over what timescales? What's the best indicators to identify this sort of impact? And what are the standard operating procedures so that we can use for monitoring, so that we can ensure that the measurements are repeatable and comparable across the ecosystems and across suites of ecosystems. Thank you very much, and happy to take any questions at this point in time.